It's summertime and the pesky mosquitoes are back with their costly bites. Costly both for human health and the economy. A study published by a team of scientists from the IRD in Montpellier calculated the global economic costs of 3 mosquito-borne diseases, chikungunya, Zika and dengue. To find out more, I am at the IRD in Montpellier, and joining me now is Frédéric Simard, who is an entomologist and the leader of the team that was involved in this study. Thank you very much for your time. What are the findings of your study?
So we've reported that these 3 diseases that are vectored by 2 mosquito species have costed a global cost of over 95 billion US dollars over the period of 45 years from 1975 to 2020. So this is a huge economic cost that is associated to this huge cost in terms of human lives. We've shared this cost into 3 different categories. So the direct costs, like medical costs, for example, indirect costs, like absenteeism, and costs that are non-monetary. So this is only the monetary costs that we're talking about. And we've also shared this cost into who is paying for that, either the individuals, where you buy, for example, mosquito repellents or medication that is not reimbursed, for the social system also, like all the treatment of the people that are affected by these diseases, and the losses, so damages that you need to pay to repair, and costs, losses, something that was planned and didn't arrive, for example, impact on tourism. For example, when you have an epidemic somewhere, people don't go and travel there, so it's typically a loss. So we've shared everything, and we're based on only the reported costs that we have verified. We have dived into the scientific and grey literature, all the reports mentioning costs associated to these diseases. We've verified this cost. We've avoid duplication of the cost, run references, for example. So this is no simulation, no expectation, really what has been reported. So it's really the basis, what it costs, and it's already huge.
Now you're seeing the mosquitoes responsible for these 3 diseases in this box. Why did you choose the tiger mosquitoes as a subject of your study?
Well, first of all, because it's an invasive mosquito. This mosquito originated from Asia and spread throughout the world, starting only in the 1980s. It came in hexagonal France, in continental France, in 2004 only, and now is present over 80% of our territories, where it's transmitting this disease now. Every year, each summer, we have several cases. So it's a real threat, a real public health threat that is coming to us, and that is global. Those diseases are expanding, so that's why we're focusing on this specific mosquito. In France, we have 70 different mosquito species. It's the only one able to transmit these diseases. So that's why also it's a focus for public health and for research.
How has climate change impacted the proliferation of these diseases?
Of the mosquitoes themselves first, climate change is not the main driver of the spread of these mosquitoes. It's more linked to urbanization. This mosquito is adapted to the city, so urbanization helps him to find suitable environment everywhere on the globe, and more on globalization and trade, international trade that have vehicled these mosquitoes everywhere. And then the global changes are facilitating the adaptation of the mosquitoes where it lands first, where the environment is more suitable, and also will spread the season of mosquito presence in temperate environment. So also, if we're speaking only about temperature, increase in temperature will increase the speed of biological processes, so increase the development of mosquitoes and increase the development of the virus inside the mosquito. So all of this will increase again the risk of transmission. So climate change is not the main driver of mosquito spread, but it will help it and will boost the spread and the amplitude of the spread.
Can you tell us more about mosquitoes in general? Are all mosquito species harmful, or do they also have a useful purpose?
Mosquitoes are not all disease vectors. Out of the 3,500 species that we actually know, only 200 of them are able to bite humans, otherwise they bite other things, other animals. And out of them, only a handful is able to transmit disease like dengue or malaria or West Nile viruses. So it's really a handful of disease vectors among a wide biodiversity of useful mosquitoes.
How are they useful?
They are useful because they are involved in a number of ecological services. At their larval stage in the water, they feed all kinds of insectivores in the water and also in the air when they are flying. They are, as adults, they also need sugar to fly, so they go on flowers and they can contribute to pollination at some point. And they also transmit diseases, so they regulate the whole ecosystem.
Can you tell us about your research here at the IRD in Montpellier?
We are studying mosquitoes that have an impact in terms of human health. So we're in the field documenting their ecology, their biology. We document their evolution, their adaptation to insecticides, for example, to global changes, and their impact in terms of disease vectors. So mainly in tropical areas for the moment, but now that this also becomes a problem in more temperate areas, we have a global endeavor to know more about the ecology of these mosquitoes and develop tools, sustainable tools, to mitigate the risk.